Good morning, one and all present here. Welcome to the 5-day FDP on recent trends in electric vehicle technology. Successfully, we have completed 3 sessions, and today we are in the 4th session of our FDP. So today's guest is Dr. Srinivas sir from Tata Elxsi. I would like to thank him for accepting our request, and also I would like to thank the organization for allowing him to present here. We welcome you, sir, Srinivas sir.
Yeah, thank you. Thank you very much, madam.
So I would like to give a brief intro about Srinivas sir. He received his BTech and MTech degrees from JNTU Hyderabad and PhD degree from Vellore Institute of Technology, Vellore, in the area of electric vehicle battery management system. He has 13 years of experience, which includes industry, R&D, and academics. Currently, he is working as a SME, subject matter expert specialist in the Tata Elxsi Transportation and Business Unit in Hyderabad. He published 27 papers in various international journals and conferences such as IEEE, Elsewhere, Energies and Electronics, including one patent. He is reviewer for IEEE, Elsewhere, IJRER, Springer journals. And he is member of various technical chapter and societies such as IEEE, MIAENG, and MSCSIT, etc. So his areas of research interest include power converters, electric vehicles, EV fast charging, battery management system, and AI and ML techniques. So we are happy that you have accepted our request, sir. I request you to go ahead with the session, sir. Thank you, sir.
Thank you very much for the introduction. So shall we start the session for today? I'm sharing my screen. Please let me know once it's came.
Yeah, okay, sir.
Can you give me the host, please?
I have given, sir. Please check it, sir.
Yeah.
Yes, sir. We are able to view your screen, sir.
Can you let me know once it is in the presentation mode? Can you see the full screen?
Yes, sir. It is in presentation mode.
Okay. Can you see full screen or the two slides?
Full screen we are able to see.
Yeah. Okay. Thank you very much for the brief introduction. So, as madam introduced me, so myself, Dr. Srinivas, I'm working as a specialist in the Hyderabad Tata Elxsi in the Transportation and Business Unit. Today, I would like to give some brief and some of the detailed information related to the electric vehicle, a battery management system, and the charging systems. So these are the agenda which we are going to be discussing in my presentation. So I will give some brief introduction about the electric vehicle and what are the major components in the EV and how many types of batteries are there we are using in the electric vehicle and how to select a specific battery for the specific applications and how in this battery, how the battery management system will work and what are the technologies we are available in the battery management system, what are the sub functions will be there that we are going to discussing in the following battery management system. Later we will go into discussing about the types of EV charging system. So how many types of charging systems we have and what are the standards we need to follow while we are going to making any kind of EV charging system and some EV charging overview, how we can do and what are the charging topologies they are following in the different countries, and followed by the question answers. So if in between also you have any questions, you can also post in the chat during your presentation or after the presentation. I will answer all your questions. Let's go to some introduction to the electric vehicle. So as maybe this is the 4th day, so you guys already having some information and you are all so many people from the background from the electric way in the doctorates. I saw that in the part space, so many are doctorates also there and from academic background. So you guys know that, so what is the need of electric vehicle, but the main question will come where so many people like this electric vehicle is seriously is going to reducing the air pollution or not. So you can see in this image. So actually either maybe it's electric vehicle or conventional vehicle. Both are going to produce in the carbon emission. You can see here. So from starting from left to right, again this on the x-axis, this is a conventional vehicle which is running on the petrol, and the second one will be the conventional vehicle which is running on the diesel, and the rest are the electric vehicles which are running by the different kinds of sources. Okay. So if the first one will be this is electricity which we are producing from the coal energy. So electric vehicle to charge the battery, we require the power. That power we are getting from the coal energy in this case. I will tell you why I am showing this one. And in the next case, we are going to generating the power from the conventional as well as from the renewable energy. And this one will be we are purely generating the power from the renewable energy. And the y-axis, you can see this is a carbon emission grams per kilometers. So if you go for the petrol conventional vehicle, there during a production of the vehicle and the fuel extraction, so this petrol or diesel, anything is not naturally is available. We have to extract from the crude oils. And while these vehicles are running on the road and we are producing this much of carbon emission in the atmosphere. So overall, so when we're going to use the conventional vehicle, so it's producing the nearly 250 grams per kilometer of carbon emission, which includes the manufacturing of the vehicle, individual parts, and the when we are extracting the petrol from the crude oils, and when this vehicle running on the road for its entire life. Whereas compared to the petrol, if you go for the diesel vehicle also, so petrol or diesel, both the manufacturing and the extraction process will be same. It is a sub component of the crude oil only. So up to this level, during a manufacturing of the vehicle or the crude oil extraction, the same amount of it is also going to produce in the air pollution. And when we are running on the vehicle, this vehicle while running on the road is also producing the huge amount of carbon emission. So if by replacing just with a conventional vehicle with the electric vehicle, can you able to reduce the carbon emission? No, the answer will be no 100%. Because see, compared to the manufacturing process, in the manufacturing process, compared to the conventional vehicle, this battery electric vehicles are producing more emission because the main component here we are using the battery. So during the manufacturing of this battery processing, it's going to be producing more amount of carbon emissions. So compared to the IC engine vehicles, the initial process, the electric vehicles are producing more carbon. And to run this vehicle on the road, so here we are not going to using any extraction from the crude oil or anything, but it required the electricity. That electricity, if we are producing from the coal, by burning this coal, we are producing the more amount of carbon emission compared to the petrol or diesel. So this manufacturing process we can't reduce. Maybe in future we can reduce by inventing some sustainable energy materials, which will be reduce this initial the manufacturing process also. But this, if you are using fully coal and coal energy only, so we can't reduce. So how can we reduce? One of the possibilities there, just hybrid it. So some of the power which we are using for the charging the EV, which may be generated from the for conventional electricity generation, or from the some of the power from the renewable energy, because entirely at a time we cannot replace. And as we also know that the generation of renewable energy, it will occupy more place compared to this conventional coal energy. So the land problem is there, and this renewable energy is not available in all the weather conditions. So in geographically, we can go for some countries there we have every time there is a fully cold or ice only. In that cases, we can't use the solar, or sometimes it is also not possible to use the wind also. So wherever it's possibilities there we can replace, and we can use a mixture of the conventional and renewable energy source. We can reduce some amount of this carbon emission. So when it then that will come to the less than the compared to the petrol and diesel. And if you want to go some more level, so like our Indian region is a very conventional for any kind of renewable energy sources. We have different kinds of weathers in 3 seasons. So in each season, we can able to produce a different kinds of energy, as solar or wind, like this kind of we can produce. If you are using fully renewable energy source to charge the vehicles, then we can reduce this carbon emission for each vehicle from approximately 250 grams per kilometer to 100 grams per kilometer. This is only we can done by electric vehicle manufacturing, and that vehicle we are charging with the renewable energy sources. So we know, so how much of difference is going to be affected. So in this image, you can see that this pandemic during 2020, it's given a lots of lessons for the overall any country. Like India also, we can see here before lockdown. This is a very famous place in our India, Delhi, right? There, this image you took in the November 19, 2019. And this rest of the half image is took during the lockdown. So you can see there, due to these vehicles, when the vehicles is running on the road, this much of pollution will get. Pollution not only causing this only carbon emission. Please, can you mute? Yeah, thank you. So this will possible only when our vehicles which are running on the road, which are not a conventional vehicle. If we are running with electric vehicle, this pollution will not happen in the road. This may be happen somewhere where we are generating the energy electric vehicle, which is not going to be affecting the human beings. But it cannot be run long run, because compared to the IC engine vehicles, this EVs are producing the more amount of carbon emission. So we can reduce slowly by replacing this conventional electricity to charge the vehicle with the renewable energy. So only one possibility is, that is, we have to convert our conventional vehicle to electric vehicle. So as we know that, I would like to give some more detailed information. So types of vehicles, we know that already, but I would like to give some information. That is, we can divide this electric vehicle as a IC combustion vehicle that you guys know very well, which you are using already. So in electric vehicle also, we have different types of electric vehicles. So which one in that one is the purely battery electric vehicle. So this battery electric vehicle will produce is nothing but which is running on the purely on the battery. And the fuel cell electric vehicle. So fuel cell is also one of the alternate energy source which you're going to using in future electric vehicle. Is most of the future fuel cell electric vehicles are under research. They are not implemented on road as of now. And other type of the electric vehicles are the hybrid electric vehicle, micro hybrid, and the plug-in hybrid electric vehicle. I will explain in detail in the upcoming slides what is the meaning of that. Okay, so this the conventional vehicle means the fuel, engine, and the transmission. Sorry. So in the fuels, sorry, I'm getting this wrong. Right. Can you see my screen, please? Anyone can confirm?
Yes, sir, we are able to see.
Yeah. So when we go for the conventional vehicle, so only fuel and the IC engine will be there, and from that we are going to convert in this fuel energy into electrical energy and given to the transmission system to run the vehicle. Whereas in the hybrid electric vehicle, the fuel cell system, whatever the IC engine vehicle will be there, that will be continue as a part, but that some of the energy we are also producing from the battery. So in this hybrid electric vehicle, if it is not a plug-in means we are going to be charging the vehicle with the external source. Whereas in the normal hybrid electric vehicle, what we will do, we will charge this battery through the regenerative braking or the motoring action. So while this vehicle is running in the conventional vehicle mode, the transmission will be rotate with the help of this engine. So during that, so whatever by using regenerative braking, we are going to generate in the energy to charge this battery. So when we are going to switching from the IC engine to battery EV mode. So during that time, what we will do, the stored energy we are going to converting into the electrical to mechanical by converting this motoring action. So here the motor which present, it will act as a motor as well as generator. Now pure battery electric vehicle is consisting the only motor. So which is get the supply electrical supply from the battery. And this battery we can also use to charge by using the regenerative braking, or by using the plug-in electric vehicle, we are going to be externally charge this battery. These are some major types of electric vehicles are present in the market. So whenever we will go for the buying for any new things, so first thing in our mind coming like, what is the benefit if I will switch from if I buy some new thing. So here also we are going to using this IC engine vehicles from the nearly since 100 years. Okay, so in the first one, it will come in like a first comparison. We'll compare what is the price when I switch from the IC engine to electric vehicle. So as of now in the market, compared to the IC engine, the electric vehicle cost is more, because the only primary reason is it's car batteries. The car batteries which we are manufacturing as of now, the available resources, which is going to cost more compared to the
Sir, your screen is not shared, sir.
okay, just I lost the connection. Can you see my screen?
Now we are able to. Again, it's disconnected, sir.
Just 1 minute. I think I have a net issue. I'm changing Wi-Fi.
Okay, sir. Yeah, now it's shared, sir.
Yeah, thank you.
Yeah, fine, sir.
So first one we will compare is a price. So because of this battery, we have more cost compared to this IC engine. So as of now, present days. So well, in future, the once the every company is starting, so more number of competitors will come in the market in the EV battery manufacturer. So then automatically it's the cost of the battery is also going to be reduced. And one of the other problem for this battery for more cost is the limited resources. So most of the vehicles as of now we are using the lithium batteries. So lithium resources are limited. It is not unlimited. So the extraction process and everything is going to be in some companies' hand only as of. So that's why the cost is of the battery is very high. Now, second point will be coming to that running and maintenance cost. So compared to the IC engine vehicles, the petrol or diesel, the running cost of the EV is very, very less. I will show you the one small comparison also in the upcoming slide. And the other benefit is the oil changing in the engine. If you are using the any conventional vehicle or bikes, you know that so you have to use the engine oils. So that is not required in the electric vehicles. And our central government and state governments also, so lots of tax benefits are also providing to the if you are purchasing the EVs. So in that point of view, the road tax also will get some benefits. But and this is also creating the employment, because to repair the electric vehicle, we cannot give to the some normal outside roadside any repairing shop, because it's required a skilled person to repair this one. Why? Because the main reason is our batteries one. Here our batteries are the very high capacity ratings. It's in the kilowatt. If any unskilled person, it will be try to open it or doing any miscommunication or thing, then it may be chances of the very huge effects. It may be some burning of the car, or is going to be death also the person who is going to open in the battery. So that's why. So when we are going to be using this electric vehicle, we require some skilled person. This is also going to generating some employment. And but the disadvantage of is the insurance cost for this electric vehicle is, as of now, it's more compared to the IC engines because of its safety levels. As of now, India is going to following some international standard levels, and as well as we are going to following the ARI standards. So still we require to some common standards in terms of the charging and batteries. So that I will explain why we are not that much of compact or flexible in this point of view. So that's why the insurance cost is going to be very high in the EVs. And the next comparison will be the pollution. As we know that the EV is not going to produce in the any kind of pollution when we are running the vehicle, but during a charging it's producing, as I explained in the first slide. But it will going to require more number of energy. So how much of energy we can able to produce as of now, and how we are going to producing, that I will explain in the upcoming slide also. So energy efficiency. So at converting onboard charger propulsion, the IC engine relatively inefficient compared to the EVs. So EVs efficiency is more. So how that EV efficiency is more, I will explain in the one next slide. This is called the very well concept. Everyone knows that the well to wheel efficiency concept. So from extracting the oil to well the vehicle is running on the road. So in the energy efficiency point of view also, electric vehicle are the more efficient compared to the IC engines. So other one is the sound pollution. So as we know very well, the EV motors will not going to produce in the in that much of noise like IC engines. So this is called the very well concept is well to wheel efficiency. That means so extracting the energy or the power. Let example we are going to be generating the electricity from the diesel generator as an example, and the same crude oil we are going to extract in this petrol or diesel. So when you compare in the both the processing starting with the initial well, then we can say so the 33% of efficiency only we are getting well after extracting all the oils from the crude oil. Then during a transmission we'll get the nearly 94% of if we are going to transmitting that one. And during when converting from the charger, so these charges will be not directly whatever supply we are getting, we cannot give to the directly to the vehicle. We have to give the some standardized charging level, voltage and currents as per the our vehicles. So that in this process, we'll get the nearly 31% of the efficiency. And overall, when we are given to the plug-in electric vehicle, we'll get the 76% of losses. So finally, we'll get the nearly 23% of efficiency in the electric vehicle when it is going to be on road. So similar process when we are going to compare to the IC engine, in the refining the petrol or diesel, extracting, separating, this will go to nearly 82% of efficiency we're getting there. And then a transmission, we will get the near 98%. And when we are converting this petrol, we are going to storing, as we know that in the petrol or the petrol bunks, we are going to store in this in the wells. So there we are getting nearly 80% of efficiency. And when we are petrol, we are going to pouring inside the our vehicles. So after converting from the chemical energy to heat energy, then mechanical and transmission, like this all the efficiency, if you are going to eliminating all the losses, then finally we'll get the 13% of efficiency, which is 10% less compared to the EVs. So that's why. So well, we are using the same input, like we are going to generate the power from the from this petrol or diesel engine generator, and the same thing, but we are getting the more efficiency in the electric vehicle due to the number of losses during the transmission level to wheel level. And so how much of profit we are getting here, as I said that, so how can we compare the cost? Here I took the one small example is a Mahindra Vitro vehicle and the same Mahindra E2O vehicle. This Mahindra Vitro vehicle giving a 15 kilometers of mileage approximately as per the standardized. Okay. As of now, we can take in the different states, we have different cost, but on an average, we can take as a 100 rupees per liter. So if I want to go for a 60 kilometer, So 15 mileage. So how much we'll get? We require the 4 liters of petrol. 4 liters of petrol into 100. So it's almost cost of 400 rupees to travel for a 60 kilometer. So whereas Mahindra it will give the 60 kilometer per 10 units of charge. By consuming 10 units of power in the battery, it's going to give the mileage of 60 kilometer. So approximately you can take the 4 units per rupee, 4 rupees per unit on an average I'm taking here. So if you compare this one, so 4 units equal to 10, 4 rupees into 10 units. So it's nearly 40 rupees. So if you see here both, here we are consuming, we are spending the 40 rupees to travel the 60 kilometer with EV. Whereas in the conventional vehicle, we are spending the 400 rupees, which is a nearly 100 times more compared to the IC EVs. So that's why the running cost of the EVs are very less. Maybe initial cost is high, but running cost is very, very less. So to run this vehicle, so how much of power we are able to generate? Excuse me for this one. So I don't have that much of recent data. So I have used this 2020 up to, but the data is available for our power generation as per our Indian government websites. So when we are going to replacing all the IC engines with the electric vehicle, so can we able to use that much of power is available with our India or not? So this is some statistics which is in the power we are generating from the different kinds of sources like thermal, diesel, hydro, gas, and renewable energy sources. So as of now, so India own consumption itself is a totally is the 137 billion kilowatts of power. If you go for the per capita, it will be nearly 832.91 kilowatt hours of power consumption. But where production will be the 1,03,836 billion kilowatts of power. In per capita, if you're taking this one, so 1,004.34 kilowatts of power for per capita production we are doing. And we are also importing the power from the private sectors. That is nearly 5.62 billion kilowatts of power. That is in per capita is a 4.07 kilowatts of power. And we are also exporting to the some private customers and the some small countries which is near to us, like Andaman or small countries you can take where we are not their atmosphere is not supportable for the generation of power. There we are going to exporting. It's nearly 5.15 billion kilowatt of power we are totally exporting. And so as per 2020 statistics, so most of the 56% of power we are producing from the thermal, which is 2,05,150 megawatts of power we are generating from the thermal, and 0.1% from the diesel, and the hydropower is nearly 45,699 megawatts of power, and the gas which you are able to produce the 7%, which is 24,955.36 megawatts of power. From the renewable energy sources, which is more efficient, which is more required to in the reduce the pollution, which is we are producing only 87,027.68 megawatts of power only. And we are also producing the nuclear power, that is 6,780 megawatts of power. So as I explained in the first slide, so to reduce the pollution, to increase electric vehicle on road, so we require to produce a more amount of renewable energy. Okay, so in this renewable energy, so we know that we can able to produce some different types of renewable energy sources we are available, like a wind. So out of the whatever the power we are generating, so 87,027.66 megawatt, in that we are producing the nearly 124.15 megawatt, which is a 43% of the total renewable energy source we are producing from the wind energy, and 40% from the solar energy, which is the 30,050 megawatts of power. And we have also alternate some of the biomass and small hydro and waste to power. This can also we are producing from the different types of renewable energy, which is need to be increased. Okay, and how many electric vehicles we are going to be producing? So as of now, up to 2020 December, So the 1,19,568 units was registered in the overall India. In that, 28% of the electric vehicle was registered in the only in the Uttar Pradesh, and Bihar 10%, Delhi 10%, Bengal 9%, Karnataka 8, Assam 7, Maharashtra 6, Tamil Nadu 5%, Rajasthan 5%, and rest of all other states are the 14%. So in this, there is a different kinds of segments. You can say the four-wheeler and three-wheelers and the two-wheelers. If you go to the loan segments, like different companies, and so we have different two-wheeler segment. We have produced the major players are the Hero Electric and Chinese Ampers, Aether, Revolt, and some other companies. You can see here from 2017 onwards, I took some statistics. So how many units we are selling in the two-wheeler segments or company wise. So in the 2017 is almost some nearly 100 or 200 units only they sold. But when it comes to the 2018, the amount was really increased very huge. It's nearly 15,000 of the units we sold in the India. And when it's go to the 2019, 84% was increasing. But after the pandemic, the amount was not huge reduced, but 11% will be reduced compared to the 2019. Where you go for a three-wheeler segment, there is electric autos. From 2017 itself, we have so many electric autos was there. It's nearly 8,000 they sold in the 2017, which has increased to 21% in 2018, and again the 20% was increased by in the 2019, and 2020 it's going to reduce due to this pandemic issues, but still they are selling sold nearly the 7 to 8,000 of vehicles. So annual sales when you compare to the all vehicles, so which is continuously increasing up to 2019, it's nearly for a in the 19 1,60,000 electric vehicle was sold, and which is in the 2020 it's reduced compared to the global market. So in the millions of units, so every year it's going to be increasing in the different segments in the country wise. So most of the electric vehicles so using in the as of now in Norway is one of the country where we are using the most of the electric vehicle. So this is a now current situations in India in the different segments in the two-wheeler and three-wheeler and three-wheeler some big other models and the four-wheelers, buses and some transportation other systems which we are going to be using. You can see here where we are going to be using nearly in the two-wheeler we sold nearly 7,79,158 in the two-wheeler segment in the year of 22-23, which is 179% more compared to the 2022. After the pandemic, this is going to be increased huge amount of two-wheeler segment. Whereas in the three-wheeler segment also in the 2022, we sold nearly 1,74,530, which is increased to 114% in the 2023 year. And the two-wheeler and the other three-wheeler segment in the level 5 segments, there also we found that the 167% of the increase was there. And the four-wheelers also, there is a 154% of increase again. And other buses is a 52%, and other vehicles also there is a 24% was increasing increment we can see. So these are some statistics related to the power generation and the electric vehicles which we are going to be registering and selling in our India. Now come to the some electric vehicle in detail. So as in that any vehicle we can have two types of modes of running is a front wheel drive or the rear wheel drive or the both four wheel drive. So major part will be if you go and taking is a front wheel traction motor will be there present, and the one of the here like this we will place our battery. On this battery we are placing our battery management system to control this battery, and there be some IC using integrating charging system which is going to connect it to the charger. It may be we have as of now we are not using in India bidirectional charger, but this is also one of the other possibilities which we required to implement in the electric vehicle. So when we are not as we can see, we are coming from our home to offices, or it will take 1 hour or half an hour based on the distance. Once we are coming to the our reaching our office or home, we are not going to be using the vehicles except any cab drivers or buses, they are going to continue using. But as a common public, we are not using the vehicle full day. Most of the cases when you're going for the traveling or any outstation, during that time only we are going to use. Rest of the time, most of the cases we will use 2 to 3 hours per day. So when this vehicle was in the any parking slot. So during that time, if you don't require this power, we can also charge to the grid. So for that, we require from vehicle to grid charge. So in that case, we can also connect this bidirectional charger to this electric vehicle to transfer the power from the battery to grid to save the energy as well as to for the cost reduction. So when we go to some more details inside the vehicle, so if you go see from outside, so it will have major parts will be the our electric traction motor and a power electronic converter, which is required to convert from the AC to DC or DC to DC, which are reducing step up or step down the power. Okay, and this DC power, which is going to we generally will use in the electric vehicle for the constant DC power. I will explain here in detail. So the major component will be here, and the battery charger and onboard charger. So I will explain. I think you have some idea, or else I will also explain this one. What does it mean by onboard and offboard chargers, and the transmission system which is going to use to rotate the wheels. Okay, and charging ports and the traction battery. This here we are placing our batteries like inside the passenger seats. So when you go to the some in detail, so first we will come to the charger. So from the grid we have three types of charger system we are going to use. So off-board charger means the charger will be the outside. So like a how we are going to use in the our petrol pumps, like that we will connect the one charger to this, and it is going to be using charge. So this will be two types of level 3 charge. We can have different levels of charger, level 1, level 2, and level 3. In the level 1 is nothing but a onboard charger. There we are using our home supplies, like single phase supply is enough, 120 volts to 230 volts of power supply they are using in the level 1 onboard charger. So onboard charger means the charger will be present, the conversion will be inside the vehicle, which is required to convert the DC. As we know that the battery is a DC component. So battery will store or supply provide the DC power supply. So this onboard charger means the charger will be inside the vehicle, which will convert the AC to DC. And when you're connecting it, converting in the DC, we know that we will not get the 100% pure DC. So you have to do the power factoring correction. So we will use one PFC converter, and to required level of power step up or step down. So for that we'll use one DC to DC converter, and this DC to DC converter we are going to give into the motor, which if we are using the AC motor, PLDC or PMSM motor, so required AC supply. So there we are again converting the DC to AC. And here one more thing we required here, that is the auxiliary battery. So in the electric vehicle we have so many other components like AC, lights, vapors, everything. So for that we required a small amount of voltage. We can't use that 10 kilowatt, 20 kilowatts of power directly. So that one required only 12 volts or 24 volts of power supply is enough. So for that, the same amount of power which we are going to use in that, we can also step down by using this DC-DC converter and giving to the auxiliary battery to run this auxiliary components. When you go to the main battery, so here our main battery, so from here to here we will charge if we use the bidirectional converter. So during charging, it will act as some step up converter, this bidirectional, and during discharging, it's going to step down or maybe step up based upon the capacity of the motor and the battery. And the level 2 will be the onboard charger. So this is also we are going to be using in the public charging, like outside like petrol pump, we are using that one, which require the power supply from up to 240 volts is going to be support. And the level 3 charger will be 3-phase AC or DC, which also we can say it is a fast charging. So that one we can say. So what are the standards we required to make these chargers? I will give you in the in the upcoming slides. So in this electric vehicle, as I said that we have a different types of electric vehicles also. If you go to the pure electric vehicle, so battery and the power converter, motor and transmission. This is the flow of the energy from the battery to transmission. So the entire energy will be supplied by this electric vehicle. So example, there is a Nissan Leaf electric vehicle. You can also find this model. And the hybrid electric vehicle, as I said in the second slide in the presentation, like we have two different types of hybrid electric vehicle. One is the mild hybrid electric vehicle, and the other one is the plug-in hybrid electric vehicle. In the mild hybrid electric vehicle, what we can do, the motor support the IC engine to run the vehicle, right? In our market is already available Honda JS hybrid. So this is one of the example where we can where they are using the mild hybrid electric vehicle technology. So other one is the plug-in hybrid electric vehicle. So the here I said that, as I said, so here we are going to using the to charge the battery externally. Whereas in the mild hybrid electric vehicle, we are not going to charge in the battery by externally. So when the motor is running itself, is going to be charged by the motor engine, IC engine itself. But in the plug-in hybrid electric vehicle, so external supply we are given to charge the battery. So in this hybrid also we have again subtypes also there. So series hybrid electric vehicle or parallel hybrid electric vehicle. So this IC engine and the battery fuel tank and fuel IC engine and the battery power trans component, which is going to be arranging in a different manner. Like if you go to IC engine, the motor is used for the propulsion itself directly. So all the extra at the end, the motor is only given to the transmission system. Here the supplies, the battery and the IC engine all are connected in the series to power supply for the motor control. Whereas in the parallel, so here the battery, power converter and motor is connected to the one transmission system with the here and the one fuel tank and IC engine. So both are connected to the transmission system. The propulsion of the vehicle we can do by IC engine alone or by the motor alone or both at a time. And the one more configuration is the both the series and parallel hybrid configuration. So this feature will provide the both the like high torque and high speed. And we have some examples in the already this kind of series parallel hybrid electric vehicles are present in the market, like Honda Civic, Honda Sonnet Hybrid, Toyota Pride, and the Ford Fusion and the Chevrolet Volt. They are also producing this already in the market, this series and parallel hybrid electric vehicles. So now come to the how to select the batteries and what are types of batteries we are using in the this EVs. So when you're going to selecting any battery, we have to take care of some of the basic specifications. So I will explain some major things which we require, and we have to go some more in detail, but we are not going here. I'm giving the overview requirement, major requirements. So when you go for the electrical requirement point of view, we have to check the what is the maximum voltage and minimum voltage our battery. So when we go for the electric vehicle battery, it's a rechargeable battery, it's a secondary type batteries, right? So what happened? When you take the initial new battery, what happened? It will be having a maybe the example I'm saying. Let us assume one cell in the battery having a maximum capacity is 4.2 volts at the initial. But when the life will be goes, like number of times you are charging, recharging, the amount of the capacity of the battery is going to be reducing. So up to what level we can reduce, we have to check it, right? So if you go for any data sheet, they will mention related to the battery specifications, like maximum voltage will be the 4.2 and minimum voltage will be the 3.5. When the battery voltage is going to beyond this 3.5, the battery start draining. You can also observe same things in your mobile. When you are buying a new mobile phone, it will come to the charging like a 2 days or 1.5 days, 3 days. But as the time goes, the battery is not providing the same amount of power. It's going to be draining. When you charge for, it will come for only 1 day initially. Then again, it is going reducing for half day. Like that it will go. Then later we will charge for every 1 hour or 2 hours. What we will do, whether we will buy the new phone or we will replace the battery. The same thing happen with the EVs also. So we have to check the battery, whether it's suitable, what is the minimum and maximum voltage levels, and how much of current it can capable to produce the maximum, minimum, and average. This is a very important point, because when we are going to run in the vehicle, we are drawing the most of the current from the battery. So in that time, so each cell in the battery, how much of current it can capable to produce. There is also one of the major requirement in the electrical point of view. And intermittent load. So like when we are running in the vehicle, we are continuously not pressing the pedal. Okay, we are going doing the stop, run, like that we are doing. So when we are giving that kind of pulses, that when say the pulse load in the EV point of view. So how much of current it will be able to produce, like maximum current, like at a time we can able to produce some 2000 milliamperes, or what is the average of current it can produce, what is the life. So on off conditions, so this is called the cycles of the battery. So number of cycles, so how many times? 2000. If you go for any EV battery data sheet, they will mention like this battery is for the 2000 cycle or 10,000 cycles. So one cycle means, so charging a battery from the 0 to 100% and again 100 to 0, that is called the one cycle. So like that, number of on and off, or we can say the number of cycles of the vehicle, we need to check this one. And the temperature and humidity, this will play the very major role, because as we know, in our throughout the world, different atmosphere conditions we have. So if you go for the like Arabian countries, there the temperature is minimum temperature is 30 to 40, and it will go to the 50 also sometimes. So during that, in that condition, if you use that battery which is support only the up to 40 to 50, it is not efficient. So according to weather condition of that particular country, we have to check the what is the temperature and humidity of the battery and storage temperature. And this battery is also one more characteristics, that when we are going to be parking our vehicle without using anything, so due to the internal characteristics of the battery, it's going to be start discharging. Like example, you know, you are charged your battery 100% and you are not using your vehicle for the 1 day or 2 day. So when you check, recheck again, it will not having 100%. It may be reduced some 1 or 2%. It depends upon the what kind of battery and what is the age of that battery, right? Also, you can see that in your mobiles, if you are charging your mobile 100% and you are not using for 1 hour or 2 hour, but when you check it, it's not 100%. It will be 98 or 90, 95, 7%, because of whatever the background internal applications are running. Due to that, it's going to be reducing. But whereas come to the EV battery, so we are providing the enough protection to isolate the battery from the external circuits when you are going to park in the battery, or we are not going to use in the EV. But due to the internal characteristics of the battery, it's going to be reducing some of the is energy. That also we need to take care that how much of energy, at what temperature we need to store it to get the maximum energy from the battery. At a charge and discharge condition, that is nothing but, so how much of fast we can capable to charge. So we can't wait for the 1 day to charge your battery, right? So how much of fast we can able to charge. So charging time also they will specify. So you have to check that. So how much of current with the C rate, which we call the C rating. So we can say produce from 10 C rate or 2 C rate or 1 by C by 2 rate. That kind of specification they will mention. So 1 C rate, we can say that with 1 ampere we can produce we can charge 100%. Suppose it is a 2 C rate, that means we can charge with 2 amperes. So our amount of current is double, which we are going to be charging the battery. So what happened? Then the charging of the battery, the time will be off. Like if you are going to charging with a 3C rate of the battery, then what happened? The 1/3 time, though within that 1/3 time itself, we can charge our battery. Like the charging temperature atmosphere. So what is the charging in temperature? So when we are going to charge in the EV battery, it's going to produce in the huge amount of heat. So we also need to check that. So how much of heat during a charging or discharging it's capable to hold it. And the number of life cycle, as I explained that. So on off conditions is also depends upon the number of cycles. And the storage period, without using the battery, how much of time we can capable to store it. These are the some major specification when we are going to selecting a battery we have to take care. And the other things are like a dimensions. So if as we know that, so inside the passenger seats we are going to place in the battery, and some vehicles they are giving in the some back end or front end. It depends upon the size and capacity. So if our cells are very high, big size, so we don't get any space. So in that case, so when you're selecting a battery, we have to check these basic things, like what is the height of the battery, what is the length of the battery, what is the width of the battery, and what is the weight. If we are going to be using more weight, high huge size batteries, so it consuming the more weight, so then automatically our performance is going to vehicle is going to reduce. Right? If instead of 2 people sitting in the vehicle, our mileage will be more. If we are sitting in the same vehicle, 8 members, what happened? The mileage will be reduced because of the torque required for the generator of the energy. It's going to be consuming more power. So because of that, also we need to check that what is the weight of the batteries which we are going to use it, and what kind of shape of battery we are using. We have different kinds of shape, cylindrical type, circle, square type, right? Like that. So based on the shape also, we can make the battery more compact. So we require more compact battery with high specific high ratings. So then we get the more space in the vehicle, and we can run the vehicle with the more speed and the more acceleration we get. And other some basic other things also we need to take care that atmospheric pressure. So how much of your battery can capable to sustain with the atmospheric pressure, and the mechanical conditions, like we need to protect the battery from the mechanical hazards, like we can say the nail penetrations, or when you're going on the way on the road, some speed breaker or some stone was hitted your battery, so how much it can capable to sustain, that also they will provide. And a safety point of view, so different kinds of safety protections we are giving, like over current, over say over voltage, under current, under voltage, all those things also we need to take care. And interchangeability, so when we are going to replace in the one battery with other battery, so that is the possibilities are there. In any cell was damaged, so in one battery pack of the EV we have hundreds of thousands of cells sometimes. So in that one cell may be the damage, so we need to there is a possibility we have to be check there whether we can capable to replace those batteries or not. So to replace that battery, we required that batteries individual cells also need to be available in the market. So that's why it should be marketable, whatever the batteries we are going to use. And the price, so as I said, so major part of the cost will be is the EV battery. So for that, so we also need to take care of the what is the price of the battery which we are going to be using. And the what are the types of batteries. So these are basic things. I guess all you also know that, but I will give some small basic links. Like we have two types of batteries, like primary and secondary batteries. So primary batteries, we can say this is the non-rechargeable battery which we are using in our remotes, TV remotes, or in the torch lights. So there, with some chemical energy, they are going to storing, and directly we are converting that chemical energy into electrical energy. So if you go for internal parts of this primary battery, so it will look like this. There is a one cascade jack. Excuse me. So which is consisting positive and negative terminal, and which is filled with the one cathode mix. So different kinds of chemicals we are going to be using nowadays. So nickel cadmium, nickel metal, and so many types of batteries. So in order to provide this one, we can place the one within this one zinc jacket, and in the zinc can we are going to using there is when we are connecting any load, the electrons is passing from positive to negative. But once it's the chemical energy is completed, or you can say it's completed discharge, we cannot recharge again. Whereas you go to the secondary batteries, this we can also say is a rechargeable batteries. The secondary battery having majorly three components, we can say that one is the cathode, another one is the anode, and which is going to be separated by the some electrolyte. So through this electrolyte, the anode and cathode are going to be charging and discharging based upon whether you are connecting a load or the supply. In the secondary batteries, we have different types of energy sources are available. So which you can say fuel cell, lithium batteries, and lithium capacitors also they are going to using. So in that, if you go for the energy density, it means with the less space, more amount of energy which can capable to store. So in that, fuel cell will having a more capability compared to the lithium ion cells, but this fuel cell having a some issue which is a charging and discharging, and is going to be attracting more with the atmosphere. So that's why still the fuel cell electric vehicles are in the research stage only. But this one, as of now, compared to the other like super capacitor and other energy sources, so lithium ion batteries are more energy density as of now for the power density point of view. So that's why the lithium batteries are more using in this EVs. So we have different types of batteries. So in that, lead acid, nickel cadmium batteries, nickel metal hybrid, lithium ion, sodium sulfur batteries, redox flow batteries. So these are different types of batteries which we are going to be using.
16.
So when we compare to the different terms of point of view, like so energy density and internal resistance. So this internal resistance is more very important, because if you have more internal resistance when you are charging or discharging, the battery is going to be drained very fast. So that's why. So internal resistance also need to be very less. Then we can be able to produce a more amount of current. So life cycle we can say, as I said, so charging from 0 to 100 and again discharging from 100 to 0. We can call the one cycle. So like that, the battery also need to be more number of cycles. At the charging time, so which type of battery having a more charging very quick, like that one. And the overcharging tolerance. That means suppose if your capability of your battery is only some battery is going to, you are connected to your charger and you left your vehicle there itself and it's charging 100%. Then still due to some internal character, what happened? This overcharging also maybe happen in the batteries. And during that time, so out of 100 cells, 99 cells are at 100%. But one cell is more than 100% maybe possible. In the real time, if you see that is not possible, you can say that more than 100, nothing is possible. But what manufacturers will do, they will hold the batteries in certain level. That means whatever the customer will see, it is from 0 to 100. But actual background will be it is only from some 20 to 90%. It's varying from manufacturer to manufacturer in the electric vehicles. Okay, that means this lithium ion batteries, if you are discharged 100% from 0, you cannot recharge again. So the manufacturer will hold the limits. You can say you can charge up to the 80%. If you go more than 80, we can say it is a overcharge. The battery can sustain, but the customer, it will indicate that you are reached 100%. And when you are going to discharging also, in your battery infotainment, it will show like you reach it to 0%. We have only 0%, 1% of energy left. But actually it will be the more than 1%. It may be the 16 or 17%. Why we are holding? Because of this characteristics of lithium ion batteries. Okay, if you go in the real time under 0% charging, you cannot recharge again. It will be completely dead. So that's why this overcharge tolerance also very important when you're selecting the batteries. And self-discharge capability at the room temperature. I'll explain that what's mean by self-discharge. So without using the vehicle, you are going to be parking somewhere and it's automatically discharging itself. This having that this chemical due to this chemical reactions. And the cell voltage. So if you have high cell voltage, we can use a less number of cells. And the load current at the peak, how much of peak current it can capable, and what is the best results with how much of C rating. Like I said, that C rating means, so if we are battery is a 1 C rate you're charging means with 1 ampere of capacity. It depends on what are the battery you're using. So same with 1 C rating you're charging, that means 100% will take 1 hour. Suppose with 2 C rating, it is reducing it's half of the time. Like that, we also need to check the what is the load current during charging and discharging both. And operating temperature, I already told you. So each temperature, when we are running the vehicle, the temperature inside the vehicle is going to be increasing more level. Maybe from hundreds also sometime. So maintenance requirement, how much of maintenance we required, and battery cost, and the cost per cycle to charge and discharge, and when it is available. So when you're comparing what are the available batteries, which as of now we are going to use it in the electric vehicle. So energy density point of view, so lithium ion battery is having a high energy density compared to the all other lead acid or nickel metal hybrid or nickel cadmium batteries. In the internal resistance point of view, this lithium and lead acid battery is having a very less amount of internal resistance for the 12-volt battery pack, which we using in our normal IC engines also as auxiliary battery. When you go to the life cycle, so nickel cadmium having a high number of life cycles, which is nearly 1500s each cell. And the fast charging, like typically it will nickel cadmium is giving the best results compared to other. It is a 1 hour nearly. And overcharge tolerance, so lead acid battery having a more tolerance compared to the other batteries, and self discharge also very less in the lead acid battery itself. When you come to the nominal voltage, so lithium ion and lithium polymer batteries both having a nearly 3.6 volts of each cell. And the load current, so lead acid nickel cadmium batteries having a more high capability in the terms of the producing load current. It can capable to produce a 20 C2 20 up to 20 C. Also it can charge and discharge, but we can get the most of the best results with the 1 C. So operating temperature also nickel cadmium having a very high. We can operate this nickel cadmium batteries from -20 to +60 centigrade, 60 centigrades is a normal operating temperature, not for the oven. So when the actual temperature in the vehicle is going to more than 60, it may be the nearly 70, 80, 100 also it will go. But to keep the temperature within the limit, we will use the thermal cooling or the liquid cooling. Sorry, we will use the liquid coolant system in the vehicles. It may be air or liquid or refrigerant or different types of cooling systems we have that we are using to keep the vehicle battery temperature within this specified limit. So here also nickel cadmium batteries can operate with the -40 to 60-degree atmosphere. We're coming to the maintenance required. So these batteries also required, we can see also in our inverter, if we have using if you say inverter, they're also forming on this anode cathode, there's a white kind of liquid solids is going to forming. So for that, we have to give the maintenance for every 30 days or 60 days or 3 months. If we are removing the solids and on the anode and cathode, we'll get the more life. So like that, in the EVs also, we have to give the continuous maintenance for the best performance. So in that point of view, so your lithium battery is having a very less maintenance compared to the rest of the batteries. Where the cost point of view, so lead acid battery is having a very cheap compared to others. And the per cycle, if you go for the per cycle, so one time complete charge and discharge, so nickel cadmium is approximately $0.01. If you go in our Indian rupees, we can say it is a nearly in 1 rupee or 2 rupees. That's it. So these batteries are available from since 1952. Nickel cadmiums are available, but due to the high toxic environment, which is going to produce more toxic gases, so this nickel cadmium and nickel metal hybrid batteries are we are mostly not using in the EVs. And the lead acid battery is required a huge space and a very huge weight. So due to that, we are using lead acid batteries as a only auxiliary batteries. We are not using as a fully battery to run the vehicle. Whereas a lithium and lithium polymer compared to the other batteries, so it is environmental friendly, not 100%, but less compared to the rest of the battery. So that's why we are preferring the lithium and lithium polymer batteries. So these are the existing batteries which we are going to using, but this is the future and which we are going to developing under stage. And when we are going to using any battery, we will think about the what is the cost and what is the capacity. So energy density, and we are comparing here the cost of the battery per kilowatt hour. So lead acid battery, nickel cadmium, metal metal hybrid, and lithium ion, which we saw just in the previous slide. So the future batteries will be the lithium air or zinc air, lithium sulfide batteries. So these batteries will be have more capability, energy density compared to the existing battery. So these are still under research and development, which can capable to up to more than 600 to 1000 kilowatt of energy, which can be capable to store. So these are the companies, major top battery manufacturer companies in the world. So CATL, LG, which is holding the nearly up to 32.5% in the market share, which is originated by the China. And the second one will be the LG Energy Source, which is producing the nearly 21.5% of energy, EV batteries market share up to 2021 is a Korean. And most of the companies are the Chinese and Koreans only as of now. And Japan is also there, EEB. And other rest of the countries is can hold only the 6.1% other companies. And you go for the company country wise. So 62.5% of this EV batteries are manufactured by the Chinese country, and second one will be the German. You can see here, we cannot find the India. We are in the rest of the world, which is a part of the 1.4%. So this place we need to increase to manufacture the batteries in India itself. Because the main reason we are not manufacturing because we don't have raw material. So how the vehicle battery well they will make. So as I said, we have maybe you saw this kind of batteries in different places. So this button type of battery we are going to using in our watches, and this is called a cylindrical cell, which mostly using in the EVs, and prismatic cells and the pouch cells. This is also same thing, but they are going to manufacturing in the cases. Some metal or plastics they are going to be using well back in this one, and this is a cylindrical type. So it depends upon the space. As I said, that shape and the size of the batteries cells are also going to matter while selecting the batteries. So like that. So individual cell they will take and they will put inside this, and they will make a some modules. So some 10 or 20 cells they are making as a one module, and like that they will provide the whatever the rest of the communication system and the thermal system, protection system, everything they will provide later. This all the number of modules they're going to be connected in series and parallel based upon the requirement of energy. Then the overall battery pack for the EV look like this. So let me see one more example that. So how, so number of cells which is required for the each battery. General the general formula we will use to calculate the number of cells for the series or battery is, you can say the number of cells in a battery pack. Uh, we have whiteboard. Okay. So take generally. So how many cells we required? Like number of cells with 1 minute, guys. Okay, let's overall I will explain. So number of cells required in series, we can say the formula we'll use. So battery voltage by cell voltage. So that is nothing but V battery by V cell. For example, here we can take the one example. So let the battery require 360 volts rated voltage and 14 cells in each module. Then how many cells we need to connect in series and how many modules we require. So for that, we can use some simple calculation. So we'll take the 3 different types of batteries, which we are using in the market. One is the lithium, nickel, manganese, cobalt oxide battery, lithium ferrophosphate battery, and lithium titan. These 3 we will compare. So go to the voltage per cell. The voltage of the individual cell will be the 3.6, 3.2, and 2.2. And the pack voltage we have already 360. So by using the basic formula, so if you go for this one, so 100 cells we require to satisfy the 360, and 114 cells we required for the lithium phosphate battery, and whereas the 160. Right. So similar way, if you are connecting in parallel, so how many cells we require? I have given one small example. So how to calculate these values? When you go for a C rating, so when you go for a C rating, which is play the very major role, there we have to take care of the 2 points. One, we have 2 types cell. One is the energy cell, and one is the power cell. So the difference between energy cell and power cell is, so for the high range, that means for the long range, we want to run the vehicle. Suppose the voltage, you can see here, this battery we are discharging with the rates of 0.2C, 0.5, 1C, and 2C ratings. And similarly, we are also discharging with the same ratings. These cells are the energy cells. That means it can run for the long time. you can see here the discharge capacity. So how much of power it can capable to discharge? It can capable to discharge up to the 3500 milliamperes hours when you're discharging with different types of rating. So maybe 0.2 or 0.5 C or 1 C or 2 C. But when you see here in the power cells, that means like racing cars, we require in the less time, more amount of power. There we will use the power cell, which will give the high performance. The voltage you can observe here, this is a 4.2 volts approximately starting, and it's going to be having nearly 3.2 or 3.5 or up to constant. Where you go for the energy cells, which is required for a long duration, like long drive you are going for 100 kilometer, 200 kilometer. During that time, we require the less speed but long run. During that cases, you have to select the more energy cells compared to the more power cell, which is going to deliver the high amount of power with less time. So this C rating also very important when you're going to select in the batteries. So this is one of the example for the nickel metal cathode graphite anode battery data sheet. So how it will look like. So they will provide like what is the capacity, nominal capacity of the battery, like 44 Ah, and the minimum, maximum, and nominal voltages of the cells, which at which rate we have to use it, and the recommended charger voltage. So what is charge rate you have to use it, and energy density is there. What is the charge up to, which kind of charge you have to use. So continuous charger, if you are using, we can use up to the 2C rate charger to charge this battery 44 Ah battery. That means you can use the 88 amperes battery. And if it's a pulse charging, then you can go for the up to 4 times. Like during discharging also up to 3 times you can discharge. So with the 44 into 3 times, you can discharge amount of current you're able to produce. So the operating temperature during a charging and discharging, a number of cycles. So what are the dimensions? What are the weights of the battery? Like that, this every information related to the battery will be specified in your data sheet of the battery. So this is about the up to the what is a battery and how to select the battery. What are the parameter we need to look into the battery, and how to calculate the number of cells required in the series and parallel based upon your voltage and capacity. You have to consider by reading your data sheet. So now let's come to the main topic. So battery management system. So why I explained all those things? Because we require to know why we are studying these things. So for that purpose, so what kind of batteries, which kind of batteries are better, and what we need to use it. Now come to the battery management system. So why we need this battery management system? So the main reason is we have to protect the battery from the different types of failures, like short circuiting or any mechanical damage or nail penetration or completely dry. I said no. So this lithium batteries having a one of the characteristics, like if you are completely 0%, it will be discharged, drying, it will going to be dead completely. It cannot recharge again back, because the chemical reaction which you need between the positive and negative, it's not going to happen once it's going to be dead. And from overcharging or failure, maybe the reason for any fire hazards. So as I shown you, like how we are making the batteries, we are going to connect a number of cells in series and parallel to make the modules, and these modules we are going to packing as a battery pack. So if, let example, any one of the cell having damage or due to any of this case, so what happen? It's going to also affect in the rest of the battery cells also. So it's directly going to be affecting overall battery pack. So for the purpose, we have to protect this battery from the this kind of various hazards. So for that, we will use this BMS system. So what this BMS will do? I'm giving here some major functions only. Apart from this, also will do so many other functions also. But these are the major things the battery management do. The first one is the over voltage protection and over current. So we cannot charge beyond this limit, whatever they are specified in the data sheet. And over temperature. So whenever the temperature is going to be increased, this battery management system will be going to informing a thermal management system. So our temperature is going to increasing. Please reduce the temperature by flowing the whatever the air cooling or liquid cooling through the battery pack. So to keep the battery pack temperature within the limits. And over discharge. So when we are going to be discharging the battery, we should not go beyond the limits. Okay. So for that, to keep the minimum voltage and the SOC, I think you guys having idea mean by SOC. What's the mean by SOC? So the state of charge. We can in a mobile, it is indicating like 80%, 90%. That is our state of charge of battery which we are using in the mobile. So similar way in the battery management system also, we need to know that when we are going to be using these batteries. Okay. And the SOH estimation. So SOH is nothing but a state of health. So what is the health of your battery when we need to replace it? That is also we are going to be estimate by using this battery management system. And the cell balancing. This cell balancing is also very, very important because this is also affecting your overall battery life and performance of the battery. Suppose if one cell in the battery is at the some different levels, I will explain this cell balancing in detail in upcoming slide. So this cell balancing also will be done by this battery management system itself, and protecting from the various short circuiting or open circuiting of the any battery while you are running the vehicle. This consoles also will be protected by this battery management system. So these are the functionalities of the battery management system. Let's see some functionalities which will be done by the this battery management system. In that, one is the cell balancing system. So let us assume the nominal operating voltage of this battery will be the 3 to 3.6. But when due to this internal characteristics are manufactured, if you, that is, we can say, if you are using the same company cells and same batch, but still the voltage variation will be there. If you are taking the ones out of 100 cells, if you compare the two cells, they don't have same characteristic. They have some little bit variation. It may be charged up to the 3.2. Maybe the another cell will be the 3.21 or 0.1 or 0.2, 0.3 difference will be there. This difference will be increasing by the time goes. Suppose today, if you take the new battery, there is a difference will be very less. But when the time will goes after 1 month or 2 months or 1 year, the difference between this voltage in the cells is going to be increasing huge amount. So that will going to cause this voltage level. So when we are charging the battery, what happened? Let example take here. We have some this 6 cells which are at different voltage levels initially. If you are charging this one, what happened? This battery already having 100%. So if you are still charging, what happened? It's maybe possibility of overcharging. Okay, and this cell is still very less. So even it's going to 100% also, but still it's not even charged it up to this minimum level, right? In a similar way, go to the second case like a discharging. If you're discharging this battery, what happened? This battery already having its minimum more than less than minimum volt. Okay, operating. But still you're discharging, what happened? This battery is going to be completely dead. We can't recharge again. So to avoid these kind of cases, what we need to do, we have to maintain all the voltages of the battery will be at same level. This can be possible by the two ways. One is called the passive balancing, other one is the active balancing. In the active balancing, what we are doing, we are going to be injecting the energy from the external or from within the cell to cell. We are transferring this, which one having high 100% or highest. This energy we are during a charging or discharging, during a charging, what we'll do, this energy we are transferring to this one parallelly. So this battery is charging and this battery also charging. But this cell which having a minimum, which is also charging, which energy also getting from the which having a maximum. Like parallel, it's charging with charger as well as from balancing circuit. So then all are will be charging and discharging with the same level. Okay, this operation will be done by the battery management system. So if you go to the internal battery management system, so the overall system will look like this. So we have different battery modules, and each module having some 10 cells, 20 cells, depends on battery. And the slave BMS will be there. So I will tell you what I mean by slave BMS. And from that, we can estimate the SOC of the battery. We will estimate the what is the health of the battery and what is the power of the battery inside by using this master BMS. And from this, it will provide the instruction to the thermal management system in the battery through the temperature sensors, and speed and flow of the coolant will be controlled by this BMS system. All this process will be happen through the some CAN bus. So CAN bus generally we will use in the communication in between the onboard charger or motor control ECU and the dashboard ECU. This ECUs we are going to be indicating on the user. And this BMS also communicating with the external charge station. So whenever you are connecting your charger to the battery, it is also communicated with the through the CAN bus to the external charger, like how much of SOC I have. This is my state of charge level. So when the user will say that you can charge my battery up to 100% or 80%, which will be desired. Then up to that level, it's going to give the communication by saying that external charger, please charge me up to the 80% only. Once the battery will be 80%, the external charger will maybe connect, but it will not going to charge. It is also going to be interact with the BMS when you're using the inside your car, like mobile phones or device, other device. That is also it's going to communicating. So how much of power it is going to consuming. So how up to what level it need to produce to the external ports. That is also going to take care by this BMS systems. If you go some more details, like the same diagram, if you go internally, so what are the systems we are using, how we are going to connect. So these are overall battery pack. For each battery models, we are going to connecting one sleeve. This is, we can say, is a distributed type of battery management system where one master and slave concept will be there. So from that, so battery ECU will be there, which is going to be two types of software users. One is application type of software, which is used to control the BMS, and other one is the low level software, which is used to for the EVSC communication, that is external energy source, which you are going to using to charger for the communication for that one. And through the CAN bus is also going to controlling the like this individually. So bidirectional conversion will be there on the with the onboard charger and DC-DC converter, which is used to supply the power to the motor and the motor control unit. So how much of speed and which is required, how much of torque required, based on that, the amount of power consumption is there. So it is also going to be observed by the BMS, which is also control. So as I said, there is a three types of BMS systems generally they will use. So this is called the distributed topology, where the master and slave will be there. So this master control will be communicated with the individual slave. So each example here, we can take the 80 cells of the one battery pack, where the like 10 cells as a one module. So in each module, we will place the one slave BMS. The slave BMS will be check the various kinds of function, like what is the SOC of the battery, what is the SOH of the battery, what is the voltage, current, and temperature. All this going to be sensed, and it's give the information to the master. Like that, this will connecting through the this slave and master. We are communicating through the RS-48 communication system, right? Then this master will give the instruction whether it need to be any balancing is required, or any charging is any temperature or temperature control or cell balancing. All this any functionality is required, that instruction this master will be give. But the problem, the main advantage is very simple construction. We can place each number of modules we can divide, and each module we can place our slave BMS. But the disadvantage is it's required the more number of communications systems, and as well as some more cost for each module, for each cell. Sometimes we require the slave BMS. It's costing the more its cost will be increased. Okay, to overcome that, we'll use the modular type of technology, modular BMS. There, the slave BMS will not place on the individual cell. Instead of single cell, it's going to control in the some 10 cells, like 10 cells for one slave BMS. And this slave BMS is going to communicating to the master BMS, which will going to give the instruction whether if anything is required or any fault will be occur. But the problem here is, so more number of wires and communication systems are required to communicate with BMS and slave. And one more problem is, if you go to the distributed type, if each year in each cell we have placed a one slave BMS, if any fault will occur, we can communicate, we can say that we can isolate this individual cell. But when you go for this modular type of BMS system, what happen? This slave is controlling nearly this 10 batteries we can assume. So in this 10, one cell is going to be having any fault. Then this slave, we have to stop provide a communication to one cell. So for that, so this all are continuously going to need to supply. This is going to continue, right? So it so isolation communication is very little bit difficult in this modular type of technology. But the number of PCBs or the slave BMS required will be less in this modular type of BMS system. Okay, so another one is the centralized topology. Here we won't use the any slave BMSs. So directly the master control BMS will be communicating to the all the individual cells and it will take the all the data. But here the problem is, so from only one master control we have to communicate with all the cells. So it's going to be very difficult. So other functionality in the BMS is the cell balancing, right? As I explained previously. So let assume the initially the battery is having a different level. So if we are discharging like all the cells, what happen up to minimum level? So when we start in discharging, this cell having a minimum already. So when you start discharging, this completely dry before the rest of the cells is coming to the minimum voltage. So here the entire energy we are going to waste it, and as well as this cell is going to be completely dead. If during discharging, what happen? This yellow cell is already a maximum. It's going to be overcharged. To overcome this problem, we can use the two types of balancing methods. One is called the passive balancing, other one is called the active balancing. In the passive balancing, what we will do, so which one having a minimum? For example, take here B3 having a minimum voltage compared to the rest of 3. So we will use one external circuit. With that, we will discharge the rest of the batteries to up to this level to keep the balancing. So whenever these batteries are going discharging, all are discharged with the same level. And when during charging also, because we are connected one passive like a resistor type resistor, which is going to discharge in these cells. So this amount of energy which is going to be extra charging, that is going to be we are discharging through the resistor. Okay, that's called the passive balancing. Whereas in active balancing, what we will do, we will transfer the energy within the cells or from the external source. Here in example, here I am presenting with the the energy transfer between the cells. So how it is will happen? So the B1 having a maximum and B3 having a minimum. So the B1 energy is transferred to the B3 and B4 having a second minimum and B3 having a third minimum. So the extra energy compared to B2 and B4, this B4 energy is transferred to the B2 to keep the all cells at the same level. So here we are not wasting the energy, we are transferring the energy from one cell to other cell. This we can done by different methods like using converters or the supercapacitors or capacitors or within the cell. There is a various kinds of topology, which is a very vast and big research area in the cell balancing topologies. So how this can be done, we can see this. So as I said, so here we are wasting in the passive balancing, we are wasting the energy, and to control all the cells at the charging and discharging, we require very less complex algorithm because only we are discharging, that's it. Whichever wasting having more energy during charging or discharging. And the control algorithm is very easy. But the disadvantage is we are wasting all the energy in the form of heat. And if we are charging, a number of cycles also going to be increasing, right? We are wasting energy and charging during discharging. If it's already 40%, rest of cells are 60. So 60% cells also we are bringing to the 40% to maintain the balancing. So for that, the cells are going to be discharging very fast. The number of cycles is going to be consuming more. So the life of the battery is also going to be decreases. And when we are discharging this one, so it would also produce the more amount of heat. We are going to have, as we are going to in the passive balancing, the energy we are going to wasting in terms of the heat. So the battery heat also going to increasing, which also consuming the more power for the thermal maintenance. And the more cooling is required. Whereas active balancing, the complex circuit is required to transfer the energy and high cost because we are using external source, which is a more costly. Okay, if you go use the capacitor or super capacitor, that is required some additional cost. So that's why it's costly and complexity, but more efficient. So in industry, as of now, every industry is using the passive balancing only because of the cost point of view. And this passive balancing in the real time, there's not much variation. It is a very small amount of power going to be harvesting. So to do the cell balancing, so if anybody is interested in the cell balancing research area, so you go through this slide. How many types of methods are there? Each method we can do the different research papers. So basically they're divided into two types of balancing, active and passive balancing. In the passive is very two types. Fixed one is a switch resistor. I will explain this one also with some small example. And the second one is the active. In the active balancing, we can use the capacitor based or the inductor or the transformer based, which is going to transfer energy between cell to cell. And the converter based also, we can use buck converter, boost converter, flyback converter, or quasi resonant converter. Various types of. Not only this, not limited. We can use number of converters to do the balancing. And when you go for the capacitor also, we have switched capacitor, double tied, chain structure, or series or parallel structure. So various capacitor based methods also we can use it. Here, let's see one small example like a fixed resistor and switched resistor and switched capacitor balancing. So in the passive balancing, we'll use these two methods. One a fixed resistor, another one is a switched resistor. So in the fixed resistor, what we will do, this is let us assume this is our three cells, BT1, BT2, and BT3. In the third, we are assuming it's a B3 having a high voltage compared to the B2 and B3. So B3 we need to bring to this level. Okay. Take. So let us assume here, so B3 having a high and this one having a low and this one having a very low. Okay. So what we need to do? So this one is our main priority. First priority will be we have to bring the rest of these two cells to up to this level. So what we will do initially, we will close this switch. This controller it will be sense. So this controller will sense. So what are the voltage level of each individual cells? So this will be L1, L2, and L3. So it will sense like this one having a minimum voltage. So this controller will give the instruction like close this switch and until when this cell 2 voltage V2 is equal to V1. And this also give the instruction like this cell of 1 like it up to V2 and V3 and V1 going to be equal. Up to this is going to continuously close. Okay. So these resistors will be equal. So one cell only we can do it individually. Once these are equal, then again it's going to be open this switch. Okay. Okay. Next one will be the sorry. Let's go to the switch type. So here same scenario we can take, but here what happened? The cells are at a time. It's uncontrollable. This is only single switch diode type of switch we can use it, which is uncontrollable. We can once we are going to turning on, it is going to discharge. Where in the switched one, what happened? This switch will control at a time. Here we have to do one by one. Whereas in the switch resistor, we can do all at a time. So one is during a charging also we can do it. During a charging, let us assume this is a V1 having a highest one and V2 having a low and V3 having a very low. Okay. So we have to bring all the cells to equal to V3. Which is a minimum. In the passive balancing, we are discharging the cells, not charging. So equalization. So this IC1, switch 1, switch 2, both are going to be turning on at a time. Whereas here we have to turn on one by one, one after one. The switch resistor we can turn on and turn off. Suppose doing a running also, what we will do, all the cells also into discharging. This also discharging and this also discharging, but we have to bring to the equal level. So for that, these switches will continuously turn on and turn off, switch resistors. Okay. I hope I understand. I explained clearly. And during charging also, it will not constant. Some cells, due to the I said that each cell does not having same characteristics. It may be some cells will be charged more fast, some cells will charge a little bit slow. So during that case, so during all the cases, charging and discharging, both the cases, we need to maintain the same amount of voltage. So these switches will be continuously turn on and turn off whenever it's required to maintain the balancing. Now go to the active balancing. In the active balancing, we have to transfer the energy from one cell to other cell. Let assume this V1 having a maximum V max and this V3 having a V minimum and this one V2 having a some nominal in between less than some maximum, we can say V nominal. So here, so which one having a maximum, that energy we are transferring to the, so V1 having a maximum we are assuming and V3 having a minimum. So we have to transfer this V1 energy to the V3. So how can we do? So to do that, the controller will sense, with the sensor, it will sense all the voltage levels of each individual cells. And this will give the instruction to the cell, like you can close this switch. So when we are closing this switch, what happened? This C1 will be charged and this will be discharged to the C3. And this will discharge to the C2 to C3. And this energy will transfer like this. And this is also minimum, right? So during at the same time, what it will do, whatever the energy coming to C2 and the same amount of energy is again, this switch is also going to be closed and it also transfer to the C2. So the V1 energy, V1 energy is transferring to V2 cell and V3 cell. So once this V1 and V2 is equal, then what they will do, this V1 and V2 both are turn on and it will transfer to V3. That means V1, V2 are going to transfer into energy to V3. So until this process will happen when V1, V2 and V3 are going to be equal. Once 3 are going to equal, this switches is going to be open circuit again back. This is we can use the like this way in the switched capacitor. So energy transfer from one cell to other cell. So this is a like converter type of topology we are using. I have shown here. This first one will be the boost converter. So whatever the energy we are transferring, that before going to transfer into the next cell, we are boosting that one. So what happened? So maybe we are transferring some 0.1 volt. With the boost converter, we can transfer that energy to the next cell or other cells to some 1 volt or 2 volts. Up to that, by increasing, we can do more faster this balancing. So instead of only the not only buck boost converter, we can also use the not only boost converter, we can use buck boost converter or cup converter to transfer the energy between the one cell to other cell during a charging and discharging to keep the balancing circuit. Okay. Now go to thermal management system. So I'm not going to entire deep level of this thermal management. Like how this will going to interact with the BMS system, we can say. So this is a main the before one traction motor is going to convert into the inverter to convert the AC to DC, and we are as we saw that. So this is a DC-DC converter, and this is onboard charger. So energy when we are going to connecting a charger here, so the amount of heat also going to produce. So that heat will be going to controlling by this using this coolant. So if you go for the air coolant method, the radiator will going to be cooling as a using this one. So that energy, that coolant will flow through the reservoir to the EV vehicle, rest of the components and the EV charger. So what is the main point to show this one? Because our batteries, whatever the batteries we are using, that's mainly depends upon this temperature also. So to keep the temperature within the limit, we have to maintain. Example. So when the temperature within the limit, like example, minus 14 farads, 14 farads. So the temperature minus 10 degrees, you can convert into temperature. So it's minus 10 to 50 degrees, we can assume it is an operating range. So in that, so where we are getting the better performance, battery life. So in the minus 10 degrees is a one example, not every battery having the same characteristics, but different characteristic. For example, only I'm explaining here. Don't think it is a benchmarking. So at minus 10 degrees centigrade, the battery life having a maybe more. When the temperature is increasing, you can see that battery life is going to be decreasing. So for that, so we have to keep the balance thermal temperature also inside the battery to get the better life. So for that, we have required efficient thermal management system in the BMS, in the EV. Okay. So how this failure mode analysis will happen, this is a very big topic, but just small example I will explain here. So when the temperature is increasing, how our system is going to be respond. So it will first identify the what is the problem when the temperature, if any kind of problem will happen. Let example here the over temperature is happen. Example you can take over temperature is there, the temperature problem. Then our failure, what we have to do, we have to find out that ice layer. So which layer is going to be breakdown, or it is going to be due to short circuit or anything thermal runaway. What kind of consequence will happen because of this over temperature? So it will going to find out the consequences. Based on that, it will say what happened. It may pressure the more pressure will create inside a battery, or maybe the fire will happen. So this kind of actions, who need to take the action? So BMS will take, or pressure valve will need to open, or a pressure valve to open, or what kind of action will required, that will be taken care by this in the action level. Okay, so overall results will be, we need to protect this one. So maybe the pressure will be released, or the current will be released, or thermal coolant will flow through the battery to keep the temperature within the limit. So in this way, the failure mode analysis we will do in the BMS system. So we have to find out the what are the problems will happen if any kind of failures will happen in the battery. What are the consequence? What are the actions we required, and what are the results? So this way we can keep our battery in the safe level. So these cooling systems also, we have different types of coolings. So passive cooling, active cooling, air cooling, liquid cooling, PCM based. So various kinds of cooling methods also there. So those who are interested in the research in the cooling of the battery, so they can go through this slide. So any one of topic maybe select. We have 10 minutes left, so I will go a little bit fast. Our last topic will be the EV charging. So to charge the vehicle, so we have to require some power which is come from the grid. Then we will use some utility supplier like a substation. There we are going to step down in the power levels, and we are going to the public charging or any personal charger. Then we are connecting to the EV. Okay. So as I starting itself, I explained that. So how this entire components will work. So from grid to HV battery we are charging. So when you're going to charge in the battery point of view, charging point of view, the major component will be our battery pack and our onboard charger. So onboard charger means the battery will be inside the vehicle. Outboard charger means the vehicle, the charger will be outside. Right? So anyone, if you go for the battery point of view, so what kind of protection we provide? So the voltage, if any of the component voltage where we are the more than 60 volts, so it is considered as a high voltage in the EVs, right? So for that we have to provide the some protection, or we need to provide us proper specification details, or rest of the circuits, or anything as a considering is a high voltage component in the EV point of view. Okay, this EV charging we can do in a different way, as I said. So residential charging at home, we can charge by using single level, or charging while parking at our offices or anywhere. And the other one technology is the for charging is the battery swapping. So we'll remove the EV battery and we are replacing with the new battery, or rechargeable. We can take a recharge any place where the recharge batteries are available. We'll take that one and we'll place now our vehicle. This way in the maybe in two-wheelers we can see in outside there we are taking the battery outside and keeping in the charging board, and they are taking the charger battery. If you go for the four-wheeler or the truck or bus, we can't do manually. We have to use some mechanical automatic system to replace the batteries. So these are the flow how we are going to connecting the onboard chargers. Right. So grid to ESV is a charger, and charger we are going to connect into the one card and connector. So inside the vehicle, we have an inlet, which is connecting to this contactor, and this inlet is connected to the onboard charger. This onboard charger directly connected to the battery and the BMS system. So these are the standard we need to follow when we are going to be making any kind of charger. So what kind of topology we are going to be using, like inside the charging system, that need to meet the ISC standards 16851 and sections. And for the communication in between the when we are connecting the battery to the vehicle, so charger to the vehicle, so the communication system, so ISO and ISE standards it need to meet, like communication. So when we are going to connecting your port connector to the charger, it need to find out the what is SOC, SOH, other specifications, so whether it's contracting or not. Like we are using like different kinds of petrol bunk we are using, like that different companies are also going to making the manufacturing the this EV chargers. So all chargers will not fix to so each vehicle having different kinds of charging port. right? So make the universal. So they are making the international standards. So in point of topology, communication, connector, and safety point of view, it need to meet. So these are the some standards which is required. So as I said, like DC fast charging means the charger will be outside, and the onboard charger means so AC supply we are connecting, the charger will be on your vehicle. Okay. I think we are out of time, so that I'm not going in detail. So as I shown already, so AC to DC, if you are using single phase AC, so AC is converting into DC, then DC up to the what are the battery pack level we required, then your battery is going to be charged. Either this AC onboard charger will be two types. One is the AC single phase onboard charger or three phase onboard charger. So it's also divided to the three levels we'll use. So AC level 1, AC level 2, or DC fast charging. So these are the specification which are ratings and which need to follow. These are a single phase AC charger, how it look like and what are the conditions. It can up to charge. We can use the 1.2 kilowatt to 1.92 kilowatts of AC single phase chargers are available in market, which is required the 120 volts or 240 volts single phase AC supply with the 12 or 16 amperes of current we are going to utilize. When you go for the level 2 chargers, so which is required from single phase 240 volts or three phase 440 volts power supply, which can capable to up to deliver the 80 amperes of current with the power we can deliver up to 19.2 kilowatts of chargers are available in market. With this charger, if one charge we can do it for 1 hour, we can maybe travel up to 16 to 30 kilometer. Most of this kind of charger we can found in our workplaces. So other one is the level 3 or the DC fast charger, which can capable to charge up to the 50 kilowatt or 100 to 400 kilowatts also, depends on that. But it require the voltage ratings up to 300 to 4000 volts, and the current will be the 400 amperes. So these are different types of charging ports which we are using, and what are the standards they will follow. And these are the which in countries which they are producing the this chargers and charging ports. So most of the Americans, they are using the Yazaki chargers, which is follows the SAE J1772 per single phase, and for DC charging the the Yazakis are using the SAE J1772 standards. And for the combo chargers also they are using for this one for the AC and DC. This kind of charges they are using in the America, whereas the Europeans are using the Minaxi and the ChargeMO chargers or the CCS ChargeMO 2 chargers. So number of ports and the voltage capacity ratings and standards are given here. And similarly, Japan, Yazaki chargers and ChargeMO chargers they are using. So the difference you can find it here. So number of ports when you're connecting to your battery in the vehicle, it's not be same. So each company's vehicles having different standards and different ports. So this need to be matched. And when you, these are the comparisons. So how much of capacity this different types of charger capable to produce, and what is the voltage and current rating is required, and what are the communication types of systems we are going to be using, and what standards need to follow, and which country and which supports. As of now in India, these are the vehicles are available with this charger which is connecting. So ChargeMO charger having capable to up to produce a 400 kilowatt. Most of this Tesla S model and Kia sold EVs and Nissan Leaf, these are using the ChargeMO chargers. So if though is anybody students are attending this FDPs, then these are the job opportunities in the battery management system or charging type. So modeling and simulations we can do is one of the charging job opportunities, hardware or testing, and any automotive engineering. So there is so many companies which are offering these jobs. These are references which you took from here. So I welcome to your questions. If anyone having any questions, you open for the questions.
Thank you, sir. Any queries from the participants?
Hello, ma'am.
Yes, sir.
Yeah, please.
Sir, I want to ask one question on the battery thermal management.
Okay.
Which cooling method is better for a battery?
Battery, we are using mostly the liquid cooling is the most suitable battery method I can suggest. But it depends upon the vehicle to vehicle. If you go for the, suppose you are going for the two-wheeler, two-wheeler, we can't use that liquid cooling because it's occupy the more space. So in at present in the two-wheelers, we are using the air coolant. Where we go for the four-wheeler or the six-wheeler or eight-wheeler, what happen? We will get some space for the coolant also. So for that, in the four-wheelers, we can say go for the liquid coolant or refrigerant coolant methods or hybrid liquid and refrigerant coolants.
Okay, thank you, sir. And sir, one more question is there that if suppose we are using the battery in the place where there is very low temperature, so
Okay.
that time also the battery performance is going to affect.
Yeah. So for the cool atmospheric pressure areas, there you use the heaters in the vehicles. If you go for the like European countries, they are using the cooler along with the heaters. So this heater will be connected through the auxiliary battery or direct to the main battery. So most of the cases, the auxiliary battery is connected to this heater to preheat the battery temperature. So it will maintain the temperature up to the whatever the operating temperature, minimum temperature required. Up to that, it will be heat. So it will not allow to go beyond that limits.
So that means, sir, what battery thermal management system we are having to cool the battery in the same way, is there any kind of system available to heat up the battery?
Yeah, that's why I said you know that I told you like we have coolant and heat both will be there. Like how we are using ACs in the vehicles in India, in the European countries where the temperature is always zero or near to the zero, they are using heaters. So the same heat air they are flowing, they are sending to the all the powertrain like battery to keep the temperature at required level. As I given you answer for your question. Hello.
Yes, sir. Yes, thank you so much.
Yep.
Sir, we have some queries in chat box. I will just read out, sir.
Yeah, please.
What precautions one has to take to prevent fire hazards from the battery?
So to fire hazards is the main thing will be happen due to the over temperature and the any physical damage. So for physical damage, during the manufacturing of the battery itself, they are taking the all kind of tests. So how much we can provide, they can provide. Other one is the temperature, maintain the temperature and the within the limit. So the best we have to do the optimal cooling method. So that is a required to prevent the hazards from the any temperature fire hazards. Coolant is a main, you can say in single word.
Okay, sir. One more query. What is the acceptable range of variations in SOC or voltage between each cell at which the cells are considered as balanced? Is there any standards published governing the acceptable range for cell balance?
Yeah, for SOC, we can say the SOC variations. So the difference between the one cell to other cell, it should not be more than the 5%. The limit will be the 1 to 5%, the SOCs. And the voltage level also will be like a 5 to 3%, like 4.2. Let us assume your operating voltage will be the nominal voltage is 3.6. So your voltage should not go 3.7 and 3.5. 0.1 voltage should not be variation. And for coming to the balancing point of view, any governing publication published like there is no specific standards to maintain the as of now for the balancing. So various kinds of topologies are using in the different countries. But most of the electric vehicles, they will use the passive balancing to keep the cells within the range. That is 0.1 volt.
Sir, I have another question.
Yeah, please.
Sir, is there any software available for battery thermal management system for the modeling, or we can do the things on the same?
Like we can perform this battery thermal management in the MATLAB.
Okay. Other
And
than MATLAB,
other MATLAB, so companies are using their own softwares, like we can say SOTAS, like internal tools only. It is not available in market to learn it. So I can suggest. So if you want to interested in the learn on the thermal management, so you can go through the MATLAB. That will be more helpful, because nowadays the MATLAB was updated. We have all the tools available which we need to perform the entire EV level.
okay. Thank you so much, sir.
Sir, we have one more query. In
Yeah, please.
active cell balancing, at what point of charging should we decide to do the cell balancing? CC or CV or anywhere decided by SOC, irrespective of CC or CV, any standards for the same?
No. When we are doing cell balancing, we are not going to using the CC or CV. This CC and CV method we are using during a charging of the battery, not during the balancing. So during active balancing, we have to, like as I said, that the difference between the voltage should not vary more than the 0.1 volt. As a company, these are not standardized, but we have to maintain minimum 0.1 volt difference. If going beyond that, our balancing circuit need to be turned on and it start balancing.
Anjan sir, your query has been clarified, sir. I think you are clear now.
Yeah, the answer is fine, but is it during the charging or after the charging we do the balancing? That's what I wanted to. At what stage? Suppose the vehicle is charging.
We can do all the cases. 3 cases we will do here in the balancing. Either maybe it's active balancing or passive balancing. That is, during a charging, you have to maintain the cell balancing. During a discharging, or during a vehicle in the idle condition.
Okay, thank you.
Because this, and then, I will add one more point for that also. When you go for the real time, this balancing, if you go whatever we are using in our present model which we are using, it will not happen within the seconds or minutes. It will take some hours. We will do slow discharge. If you do very fast discharging or charging for the balancing, it's going to be effective more. It cost more. So for that, so this imbalancing of the voltage itself during a battery, it is a very less amount. So that will be captured with a long duration, but 2 hours, 3 hours, 4 hours. Slowly we will do. It will not generate the additional temperature.
Okay.
So that will also save some power.
Okay, got it.
And best way is to do the balancing. If very less amount of imbalancing is there, then you can do the during a rest period. That we will done by programming in the BMS. We can say that if the balancing is 0.1 volt only, this is just touch the threshold value which you are expecting. Then we can say you can turn on after the 1 hour, or you can turn on after the 1 hour. You can do the balancing by the limits. That's how we can do it.
Okay, so currently there is no standards governing all these numbers. It is based on the
company to company and battery to battery which we are using. It depends on the characteristics. Like I said, now we have different types of batteries, right? In market.
Yes, understood.
Based on that.
Okay, thank you.
Is there any battery design software? Is there? We can design the batteries in the MATLAB. Shashidhar, sir.
Sir, which battery is actually getting more use everywhere now currently for in EV?
Sorry.
Which battery is actually getting used more that in the lithium or in the any other batteries there?
So as of now, currently lithium-ion batteries are more using in the batteries, lithium-ion phosphate.
Thank you, sir.
Yeah.
Hello, sir. Hello,
Please, yes.
sir. I am Shashidhar.
Yeah, please.
Sir, regarding lithium-ion battery, we are using, but catching fire will be catching fire as early as possible if heat it up in the warm condition.
Yes.
Hello.
Yes, I am listening. Please.
In spite of that, any graphite material coated anode or cathode material battery like that is graphene battery, can we use it?
Yeah.
How to design? Any software is there for that one? Designing?
I don't have idea to design the graphene batteries, but I can say that the graphene batteries are more high capability compared 100 times more capable to the compared to the lithium battery. But these
Yes, sir.
graphene
That's
batteries
what.
are still under research. It's not available in the market. So maybe in the future,
Marketing.
when these graphene batteries are available for EV, then it will be change the
Yes.
game changer, we can say
Our
it.
total. Yes, definitely. That some of the companies like MGM, GVM, that in Canada and the US, some of the companies are manufactured graphene capacitor as well as graphene batteries also.
Yeah, they are
For
started,
EV.
but not they are as of now they are not using in the EVs.
Yes. Any
That's
idea?
because the transformation from one technology another technology to adapt the companies, it will take time because they have to do all the research and performance, and they have to need so consider the cost point of view. You can say that if you are getting lithium ion cell in the market for 10 rupees, so if you go for to buy the graphene battery, it may be cost the 100 rupees. It's maybe 100 times more cost. So in the present market, we are not buying the EVs because of the cost. If you go for the IC engine vehicle, we'll get in the 10 lakhs. But if you go for to buy the
Yes.
EV, it merely 20 to 30 lakhs. And if
Yes.
you're changing itself from the lithium ion to graphene, we have to pay nearly 50 to 60 lakh for the same size of car.
Yes, but availability of graphene or
Graphene.
carbon graphite
It's called a
material is
single
abundant. No, sir?
molecule carbon materials.
Yes, abundant actually.
Yeah.
Can we have from different like a tar or waste tires? We can get it graphite.
That is some other concept we can say,
Yes.
like how to manufacture in the batteries, that will come in that point of view.
Okay. Okay, sir. Okay.
Yeah. Thank you, Shashidhar.
Thank you, sir.
Any more queries from the participants? I think there are no more queries, sir.
Yeah. Thank you, ma'am.
I have one query regarding cell balancing using converters.
Yeah.
You told boost converter, buck boost, CUK converters.
Yeah.
And also fixed resistor balancing, switched resistor and switched capacitor balancing.
Yeah.
So which one will be good actually now? Which one is actually employed?
So in the present market, we are using the passive balancing in electric vehicle. So there we are using the fixed one or the switched one. For the difference between these two is the control topology which we are developing. So has more control complexity your control topology, it's consuming more amount of chip size or the process program size which you are going to dumping. So that will be little bit complex. So for that, this balancing is not that much of level as of now as technology developed. So the imbalancing will be very less. So most of the present companies are using the passive balancing with fixed resistor.
Sir, are these available boost converter balancing? Is it employed currently? Not yet.
In the research paper, it is employed. So I have also done the one of the switched capacitor during my PhD.
Being I'm researching converters, so
Okay.
this is the first time I'm hearing we can do cell balancing using converters also. So I was keen in doing if there is any possibility.
Yeah, it's there. So the energy, so the research, when we go for the high level in future, we are going to using this battery size. We are increasing for the buses and every vehicle, high level vehicles also. what we required, we have huge high size, sorry, you can say the high amount of power required, then the imbalancing also will be high. So instead of wasting energy, if we are ready to spend more amount of money, then you can go for the active balancing. There we can save the energy and increase the capacity of the battery. So, well, the balancing we are doing, what we are doing, just simply we are transferring the energy from one cell to other cell, or we are using one extra cell to transfer that energy to the lowest cell. So if you are using some boost converter, let us assume I need to balance from highest cell, as I shown you for 4 cell example. One cell is transferring the energy to the rest of the 3. So if one cell is transferring, maybe 0.1, 0.1 volts is transferring individually, directly we are using capacitor. Suppose if you are transferring through the boost converter, so this 0.1 volts, you are boosted to some 1 volt, we can assume. That 1 volt we are transferring, then that balancing will be more fast compared to the general switched capacitor. So capacitors having a limited, like 10 microfarad or 1 microfarad or like that kind of capacitors we can use, because it's consuming more space. The capacitor size will be more. The same thing if we can do with the GaN switches based controllers, it's occupying the same, instead of one capacitor, we can place the 3-4 switches, and the capacity of the energy transfer will be very high. So in that point of view, we can use the converters for the active balancing. Not only boost, we can use number of topologies. So as we know that when you are using instead of boost converter, we have quasi, quadratic, so many converters. So which one is efficient, that we can do more research there. It's an add-on, it's an extension of the power electronic to the battery, we can say.
So what is the voltage level required there in transferring?
It depends on number of cells. If your combination which you are using, suppose 10 cells you are using, one cell out of that is a like all cells are not at same level. One will be minimum, second will be some more maximum, as I explained. So how much of energy you require, based on that you have to select your converter ratings. What are the inductor capacitor, whatever you take, based on that you have to select it.
Okay. Thank you, sir.
Yeah,
Any
thank
more
you.
queries from the participants? Sir, I would like to wind up the session, sir.
Yeah, thank you.
Sir, you have covered a lot of topics in the battery management system. Actually, you started with the introduction to EV and types of EVs and battery selection and types of batteries. Everything in detail you have done, and where we are in the global market. And finally coming to BMS and cell balancing topologies and EV charging standards and international standards. All these you have discussed, sir, regarding battery management system. I think this is a very informative session. Thank you very much, sir, for accepting our invitation and presenting here. And we would like to thank your organization also for permitting you. So in this regard, I would like to thank the dignitaries of the college, our HOD, Dr. R.S.R. Krishnam Naidu, sir, and Chairman of the college, Sri N. Satyanarayan Raju, sir, and Secretary, sir, Dr. N. Prasad Raju Garu, and Treasurer, Sri N. Kanakaraju, sir, and finally, the Director of the college, Dr. J. Raja Murugdas, sir, for allowing us to do this FDP, and without their support, it would not have been happened. So I would like to thank everyone in this regard, and thank you very much, sir, Srinivas, sir.
Thank you, madam. And thank you for your organization also for inviting me. So this kind of platforms also, we will get opportunity to share our knowledge with the academics, researchers, those who are interested, they can do more. So in future also, if you have any query, so you can also reach me in LinkedIn or any, I'm available. So you can search with my name. You can directly reach me also for any kind of future, any FDPs or any workshops. Always welcome. And if you have any queries also, you can please, you can come to me. I will try to answer. Thank you. Thank you very much.
Thank you, sir.